Okay, we're going to leave the definitions for a while. We're going to introduce you to some new identities. Now, you can use these identities starting now. I will not force you to, however, until we hit chapter 5. You can always, if you get stuck with your identities, you can go back, you can draw the triangle, and you can make that triangle, and you can label the X, Y, and R, and you can find things that way. So that is always an option if you get stuck, depending on what you're given in a problem. But there are other relationships in Trig that we're going to study, and eventually you will need these, so my recommendation is that you start memorizing them. These are the Pythagorean identities, and you can see that just like the Pythagorean theorem, everything is squared in them. We have sine squared plus cosine squared always equals 1, as long as the two angles are the same. So for example, sine of 30 and cosine of 30. The sine of 30, if you take that and square it, and then you add to it the cosine of 30, and you take that and square it, it has to always equal 1, which I think is really neat. So sine squared plus cosine squared always equals 1. Tangent squared plus 1 always equals secant squared. And I didn't memorize that one that way. I always memorized it as 1 plus tangent squared of an angle always equals secant squared of the angle. So I memorized it that way. And 1 plus cotangent squared of an angle always equals cosecant squared. So here you can see they mix and match all the time, and that's part of the hard thing about it, is figuring out which two trig functions go together when. So that's a little stressful at times. And I also want to point out that I don't like where trig puts the square. Trig, instead of putting the square at the end, they stick the square between the abbreviation of sine and the angle. And I know why they do it. Like, if I did it this way, that would imply that just the angle was squared. What they should do is they should put it here. That's what it means. But because they don't want to type the parentheses, and we don't want you to have to write the parentheses every single time, they don't. Most students do better, however, in the beginning if they use parentheses. It'll make the order of operation make sense to them when they're using the identities. So you could do it that way. Sine of theta, find it, square it, then add to it whatever cosine of theta is, then square that, and that has to always equal 1. That is actually how those are read. Find the sine of the angle, then you square it. Don't square the angle, just find the sine, then square it. Then find the cosine, then square it. They just, for a little shortcut, they put the square in a funny place so that you don't have to put parentheses there. We also want to, at this point, introduce you to the quotient identities, as if you haven't had enough to start memorizing already. But remember, for now, the biggest thing, you have to know the definitions and how to draw that triangle. And you have to know who pairs up with which one as far as reciprocals go. So there's a lot to memorize, but if, focus first on the definitions, go ahead and start making flashcards, and, go ahead and start learning your identities as well. There will only other identities we'll do before chapter 5, I believe, are the cofunction identities, and I don't usually make my students memorize those. I'll teach you a little trick for that where you don't have to memorize them, so that's really neat. Okay, so what the quotient identities say is that anytime you have sine of an angle divided by cosine of an angle, that always equals the tangent of that angle. So that's one that's always true. Tangent is always equal to the sine divided by the cosine, as long as the three angles are the same. It should make sense, you guys, because what's the definition of sine? Y divided by r. And what's the definition of cosine? Cosine. X divided by r. And if you divide fractions, you flip the bottom, and what happens there? The r's cancel, so you get y over x, which is equal to tangent. So it is true, that's always true. It's also true that cotangent of an angle is always equal to the cosine value divided by the sine value. So tangent is sine divided by cosine, and cotangent is cosine divided by sine.
They're reciprocals. So then you just flip it.
Yes, they are, because they're reciprocals. Does that make sense, you guys? Since tangent and cotangent are reciprocals, if tangent equals sine over cosine, then cotangent has to equal the reciprocal of that, which is cosine over sine. So technically, if you know one, you could find the other just by the reciprocal. So to me, trig is sort of like, I don't know, it's almost like an incestuous math, you know, like there's so many relationships that everything like is related to everything else in some weird way, and it just kind of makes students uncomfortable. But you do have to go ahead and start memorizing those. So here's our next example. It says, find the sine of theta and the tangent of theta if we know that cosine is equal to negative square root of 3 over 4, and we know that sine is positive. So we'll pause for a second, let you jot that down and try to wrap your brain around it. Okay, so here, let's just kind of take it apart slowly and talk about the givens. Here's what I was given. I was given that cosine is negative square root of 3 over 4, and I was given that sine is positive. And I don't want to find the other 4 trig functions, I only want to find 2 of them. I want to find sine and I want to find tangent. And I had to tell you that something else, because if I just told you that cosine was negative square root of 3 over 4, we wouldn't know what quadrant that was in. I know it's not 1 or 4, but it could be 2 or 3. Does that make sense? So you needed to know something else to help you find the quadrant. So in this case, we know that it has to be in quadrant, which one?
1.
It can't be in 1 because this is negative.
Oh, I thought.
So if cosine is negative but sine is positive, it has to be in quadrant 2, right? Yes? Okay. So it's out here in quadrant 2 somewhere. Now your book is wanting you to use identities to find this. Like they're wanting you to say, okay, we know that sine squared plus cosine squared always equals 1, right? So that's what they're going to want you to do. And I'm going to do it that way just for now, and then I'm going to erase it and I'm going to do it another way, and I'm going to encourage you to do it the second way for now because it will be less complicated for you in the long run, okay, for now. And once we hit chapter 5, we'll do a lot more of this, you know, the other with the identities. But I just kind of discourage using the identities this early on because I think it's too stressful for students to kind of see the connections. But let me show it to you, but you may not want to write this way down. So if I know I'm over here in quadrant 2 and I want to find sine of theta, and I know that sine squared plus cosine squared always equals 1, then I know that sine squared plus, what was the cosine? Negative square root of 3 over 4 squared equals 1. So if I take the cosine out and I substitute in the number and then I square it, that gives me sine squared plus 3/16 equals 1. Then you subtract it and we say that sine squared, so we're just doing algebra here, it's a little weird. Subtract 3/16 from both sides just like you would if you were solving an algebraic equation, and we get 13 over 16, I believe. Someone verify that. 1 minus 3/16 is 13 over 16, I think. Yes? Okay. Now how do I get rid of a square from algebra? You take the square root of both sides, definitely. And then we know that sine of the angle has to equal plus or minus, because when you take the square root, you have to do plus or minus the square root of 13 divided by the square root of 16, which is 4. And it told us in the beginning that sine had to be positive. So now the problem is, that part of the problem is done. I personally think that's a lot of work for very little information. I've done all that work and I've only found one of the other trig functions. So this is usually not my desired method here. You know, if I'm not specifically told I have to, I won't use the identities. But let me find tangent and then I'm going to erase everything, go back, and I'm going to show you what I think is an easier way to do it. If I want to find tangent, and I know sine and cosine, what does tangent have to equal? Sine divided by cosine. So in this case, that's my sine, square root of 13 divided by 4, and then I need to divide that by cosine, negative square root of 3 over 4. And when you divide fractions, remember that you flip the bottom, change it to multiplication. So we have square root of 13 over 4 times negative 4 over the square root of 3. The 4's cancel, and I have negative square root of 13 over square root of 3. And I'm still not finished. Now I have to multiply top and bottom by the
Square root of 3.
square root of 3. And that would give me the negative square root of 39 all over 3. I just think that was an insane amount of work for a problem that probably shouldn't have taken me that long. So I don't usually like to use the identities. I would prefer to go fill in that triangle from the very beginning and use the definitions and draw it out and then just stack them up. I think it's much easier. Is it okay at this point if I pause and erase it and we kind of start over? And we'll do it from the definitions. So let's start over, and rather than using the identities that we just learned, I say learned, I know them, most of you probably don't yet, you have to go and memorize them. So it's kind of hard to use something you don't really know. But we're pretty comfortable with the definitions. So let's redo it with the definitions. If cosine is negative but sine is positive, we're out here in the second quadrant. There's my angle. And I know that cosine is the x value divided by the r value. So I know that negative square root of 3 over 4 is equal to x over r by definition. So that means that the 4 is the r, and the negative square root of 3 is the x, and all I'm missing is the y value. And once I complete that triangle, I can find any of the 6 trig functions that I want. So it'll certainly be easy just to find 2 of them. So if I use the Pythagorean theorem, and I say x squared plus the missing y squared has to equal r squared. Does everybody understand where I got the 2 sides from, the definition? Now be careful with a negative. You can never give the negative to the r. You have to always give the negative to the x or y, and that depends on what quadrant you're in. Okay? And in the third quadrant, x and y are both negative. So that causes trouble sometimes. So as you're kind of working through. X squared is negative square root of 3 squared plus the missing y squared equals r squared. So negative squared is positive, square root squared, the square root disappears. So we have 3 plus y squared equals 16, thank you. So that means y squared is 13, and y is plus or minus the square root of 13. And because I'm in quadrant 2, that y value is positive. Now if I come over here, I can say sine of theta is y divided by r, which is square root of 13 divided by 4. And I am finished. And I think that is much, much easier than using the identities. Then I can find tangent as well by simply saying y divided by x, which is square root of 13 divided by negative square root of 3, which will rationalize to negative square root of 39 divided by 3. What do you think? Which way did you guys prefer?
That one.
This one? Okay. So for now, if you don't want to use the identities, even if your book tells you to, you do not have to. But somewhere along the line in chapter 5, I'm going to have to make you do a few of them. Just because before you get deep into chapter 5, you have to get used to using those identities numerically. But for now, you can go back to the definitions. Okay. We're going to kind of caution you right here. If you are using the identities, remember that when you take the square root of both sides, and that's true even with the Pythagorean theorem in this case, you have to consider positive and negative. And you always choose positive or negative based on what quadrant you are in. So be careful when you're drawing these diagrams and make sure you don't leave any negatives off. And for our final problem, I want you guys to work on this one. I'll pause and give you a chance. So let's read through it together, and then I want you to do it. And instead of using identities, I want you guys to use the definition again, because I want you to do draw the triangle and get it understood that way. I'm going to give you that tangent of an angle is positive 4/3 and that the angle theta is in quadrant 3. Given just those 2 pieces of information, I would like for you to find the sine and the cosine value of that angle. Okay, so if we're using the definitions, the first thing we do is we go out to quadrant 3 and we locate a point out there that we rotate to. We draw the triangle to the x-axis, and then we know that tangent is y over x, so that means that 4 over 3 has to equal y over x, which means that the x value needs to be 3 and the y value needs to be 4. But there's a problem there. Because we're in quadrant 3, both of those actually need to be negative. Because if I'm going to graph an ordered pair out here, to get there, I have to go -3, -4. And that's one of the hardest things about trig is not ignoring your negative signs. So make sure you put negative and negative there. And then you can see that when you do stack that -4 over -3, you do get +4/3. So be careful. You have to just pull the negatives kind of out of thin air and know to put them there because you're in that quadrant. Use the Pythagorean theorem, x squared plus y squared equals r squared. So in this case, x squared is 9, y squared is 16, and r squared is 25, which means r is plus or minus 5. But because we're in this whole trig situation, the r value is always positive. So we got x equals -3, y equals -4, and r equals +5. So that means that sine of the angle must equal y divided by r, which is -4/5. And cosine of the angle, and those were the only two we were asked to find, x over r, which is -3/5. Is everybody cool up to there?
Yep.
I have one other question for you and then we'll be done. What would I have to get if I took sine squared plus cosine squared and added them together? 1. So if you wanted to check your work, I'm not saying you would, but just to see the connection, because of that identity, sine squared plus cosine squared always has to equal 1. So let's check and see if it does. -4/5 squared is +16/25. -3/5 squared is +9/25. And that equals 25/25, which does equal 1. So there are all these connections that you need to start seeing in trig. But for now, focus really hard on your definitions and your reciprocals and go ahead and learn your ranges.